Question 2 says that the diagram shows the curve with equation y is equals to 2x square minus 5 over x plus 3. The curve crosses the x-axis at the point P. This is the point P that is having coordinates 1, 0, and M is the minimum point. This is the minimum point. Find the gradient of the curve at P. So if we want to find the gradient of the curve at any point, we need to find the derivative and put the x coordinate in that derivative to get the gradient of the curve at that point. Okay, so let's begin that. First write the equation of the curve. Y is equals to 2x square minus 5 over x plus 3. So dy by dx will be derivative of 2x square is 4x, and as let's write this in a more 5x to the power minus 1, because we cannot differentiate or take derivative in the denominator, so we need to take that to the numerator. So first try the simplified form and now differentiate it. So the derivative of x to the power minus 1 would be minus 1 x to the power minus 2. So minus of minus 5 is already there, so minus 5 multiplied by minus 1 x to the power minus 2 plus 0, because the derivative of 3 would be 0. So it will give you 4x plus 5 over x square. Now this is the general equation for the gradient of the tangent, okay, at any point of your quadratic of your equation that is given to you. But to find out the gradient at point P, we need to substitute x equals to 1, that is the x coordinate of point P. So at P10, dy by dx will be 4 times 1 minus 5 over 1 square. So that gives you 9. 5 plus 4, 9. Okay, so this is the gradient of tangent at point P, or you can write, okay, gradient of tangent at point P. Now what is the next part of this question? We have found this already. Part B says the find the coordinates of M, give each coordinate correct to 3 significant figures. So whenever we have to find the coordinates of a stationary point, we put dy by dx equals to 0. Why we put that equals to 0? Because at that point, okay, the slope of the tangent would be is like parallel to x-axis, and the slope of any line parallel to x-axis is 0. So whenever we need to find the gradient of the we need to find the coordinates of the stationary point, so we always put dy by dx equals to 0. So now we have this dy by dx already with us. We already differentiated this equation. So let's write this up and now put this equals to 0. So put this equals to 0. Now multiply the whole equation by x square, because x square is in the denominator, so as to solve it. So it will give you 4x cube plus 5 equals 0. Then x cube will equals to minus 5 over 4. Okay, and x will be equals to, taking cube root on both sides will give you some decimal value, and the decimal value should be up to 3 significant figures. So first write down what it is. It is minus 1.3 0.772. So up to 3 significant figures, it would be minus 1.08. Now we need to find the coordinates. We also need to find the y coordinate for this point M. Okay, so putting this x value in equation of y, we will be getting y is equals to 2 times minus 1.08 square minus 5 over minus 1.08 plus 3. When solved, it is going to give you y equals to 9.96. So your M coordinates would be minus 1.08 comma 9.96. That's all about your question number 2. We found the coordinates of the stationary point as well.